so that there's no feedback.
Okay.
Good to go. All right. Hi, everyone. My name is John Kruper, and I'm going to be talking about object-oriented programming in Python. If you have no previous familiarity with object-oriented programming or no familiarity with object-oriented programming specifically in Python, this will be a great tutorial for you. If you're already very familiar with these concepts, you might pick up a thing here and there, but feel free to also be doing other work. I don't want to like bore you or waste your time. Can everyone hear me? Awesome. All right, I have this little instruction set here for where to find the Slack channel. If you have any questions, particularly if you're on Zoom, if you're in person, you can also just raise your hand and get my attention. The Slack channel is called Kruper-ADB Python. And to join it, on the left side of Slack, you can see your list of channels, and below that there's an add channel button, and you can type in that name and you should be able to find our channel here. All right, and finally, in terms of sort of beginning announcements, I'm going to be punctuating this lecture with a series of exercises, which are in this Jupyter notebook. This Jupyter notebook, if you pull up the curriculum link and go into Kruper-ADB Python, it's this 01 Kruper OOP, object-oriented programming, and hopefully you can follow along and do these exercises with me. All right, any questions? Cool. So object-oriented programming is a paradigm that is based off these things called objects. Objects are a grouping fundamentally of functions or methods and data, which is in the properties. The first step in doing object-oriented programming is to create a class. In Python, it's using this class keyword. Here's an example of a class that we're calling BrainScan. It's got 3 different properties, things you might want to, some data you might want to associate with a class: patient name, scan type, and date. Classes are the blueprints, and then later you can create objects based off of this class blueprint. So here we define the class, and here we define an init method. Most classes have these init methods. They stand for like initialize. They're also called constructors. This is taking 4 arguments. These 3 are some data that you're going to attach to the class when you create your object. And this first argument is self. And any function inside of a class, the first argument is usually self, and that's how you refer to the class itself. So here's an example of the class actually in use. So the class itself is just sort of the idea, the blueprint, the overall concept. And then to make an object, which you can actually use, you're creating a specific instance of this BrainScan. So here we've created an instance where we gave it a name, John Doe, a type of scan, and a date. And is there a question on Zoom? So we have our class blueprint. We've created a specific object, John Doe, and we've passed into the initializer these 3 arguments. And you can see this scan1 object that we've created has these properties. I've been calling the data that's associated with an object, I've been calling them properties. There can also be called attributes. There anything like particular that you want to group with the functions you'll eventually add. And so we started off having this one class BrainScan, and we can create multiple different objects from one class. And so here we've got an example where we've created 2 new objects. I'm calling them scan2 and scan3, each with different attributes, but they're following the same layout. All right, so far it's just been grouping together similar variables, basically. And now we're going to add in methods. So we still have our init method. That's how we create the class, create the object from the class. And now we have this function display details. And with display details, you don't have to pass in any additional arguments other than self, and it will use the data that's already inside your object to do something. So for example, we have the scan1 that we set up a while ago. We're reinitializing it for whatever reason. And then we can call scan1.display details. We don't have to pass back in the patient name, the scan type, the date that's already contained inside of the scan1 object. So when we call this method that's associated with the object, it will just display the details. And so that's sort of the convenience. You've grouped your variables and methods that go together all into this one thing called a class. And then you can create different instances of this class called objects. And that's object-oriented programming. All right, so here I've got a first exercise. It should be pretty similar to the example I just showed. Instead of creating a brain scan, you're going to create a class called patient, and then create an initializer method, and then maybe create another method to print the details. And by the way, if you want to add in a new block in this Jupyter notebook, you can click this plus up here, and then you can start coding in here. For example, just start coding like that. So go ahead, I'll give you 5 minutes and you can fill out this example and let me know if you have any questions. And for all of these exercises, if you are having a problem, you can post your code to the Slack and we can look at it. And also, because the odds are that someone else is having a similar problem. And also, once you're done, you can post your code to Slack so that others can see the correct way of doing it. All right, are people ready to move on or do we need more time? Cool. All right, so the next concept we're going to look at is inheritance. Inheritance is a relationship between two classes that it allows us to create what's called a child class, which can use the methods and properties from what's called the parent class or the superclass. So for an example, we've already created this class called brain scans. But here we're going to create a class called MRI scan, which is a specific type of brain scan, let's say. So the syntax is right here, class MRI scan, and then inside these parentheses, you put whatever class is the parent class. The constructor looks a little different. You've got this line here, super in it, and this super keyword here refers to the parent class. And here, what you're doing, you're calling the parent class's constructor. You don't have to do this in every child class, but it can be convenient. And we're telling it the patient name, date, and MRI. So it'll run the same constructor that we already defined up here and set these patient names, scan types, dates. And then you can do whatever else you want to do in your own constructor in the child class. And then we have this other method here, display MRI details. And it's calling the display details function, again, from the parent function. So the advantage of, again, from the parent class. So the advantage of inheritance is you get to keep all of the methods from the parent class and then add in some new methods for the child class. So this is just defining what an MRI scan looks like. And then down here, we'll create the actual object MRI scan with an example person, date, and field strength. And we'll call display MRI details. And this is using the display details function we defined all the way up in the parent class before. And here I have a quick little exercise. I don't think we need to go into this right now, but if you're following along and you want to do it, go ahead. But here is just, it's basically a repeat of what we already went over. But you can create a class like T1 scan. And it's kind of interesting because you can create the MRI scan class that we called here is a child class. You can create another class that is a child of it. So a class can be both a parent and a child. So that in this example, you would create a T1 scan class, which inherits from the MRI scan class. All right, the next concept is encapsulation. This allows us to hide the internal state and processes of an object and expose only what's necessary to the outside world. This can be very useful if you're writing code that is not just for you, but it's for other people to use. It can also be useful in terms of like organizing your own code to let future self know this is the code you should be using and this is handled internally. So basically all it is we're looking at this brain scan class again. And this time we've set this underscore before the variable name. And that just indicates to anyone who's reading the code or using the code that this variable name is handled by the class's functions and is handled by the class itself, and should not be messed with outside. So for example, here we set patient name with this underscore, so it's hidden. Yeah, go ahead.
Is it a convention? Is it a requirement?
I think it's a great question. So in Python, oh, sorry, the question here is it a convention or is it a requirement? In Python, the underscore before the variable name is a convention. However, if you put 2 underscores, I don't do this often, but I'm pretty sure that then becomes a requirement where you can't access it from the outside. Right, great question. All right, so this this hidden variable is also called this hidden attribute is also called a private attribute. And here we can see an example. We create this MRI scan class, and one thing you could do with the previous attributes, so for example, scan type, if you have a specific object, you can look at the specific scan type. Let me put this in a little thing. And see it's MRI, you could set it if you wanted to change it, and then that would change it. But with these hidden properties, it's basically indicating to anyone who's using the class or object that you shouldn't be doing that. And that, for example, patient name here is only going to be dealt with the class itself. So if I wanted to get the patient name, because this underscore is here, and I wanted to print it, I should use this get patient name function instead of accessing the patient name directly. And again, when I first learned this, I thought it was a little weird. It's like, why are we limiting ourselves? Why are we forcing ourselves to go through these functions? But it's really a way of controlling the internal state of your class or object. So if you've got more complicated objects where there's a lot of different variables running around, and you want to make sure that they're all sort of internally consistent, maybe whenever someone accesses the patient name, you also have a last name and first name field that you want to update, because maybe you've got like, that would be redundant information, but something like that, where whenever someone changes one thing, you want to make sure that it's still within a valid bounds, and that the whole state is internally consistent. So it's sort of indicating to people who are using your classes, these are the attributes that I can mess with, and these are the ones that I should go through the functions to mess with. All right, so here's a short exercise. You're going to modify this brain scan class so that the other private attributes, not just patient name, are private, and you can create 2 public methods that for each of these attributes. One should be similar to this get method, and then another one which should be like a set method where you're actually modifying these private attributes. And you can also, I'm going to give you 5 minutes. You can also go back and do this exercise that I glossed over in inheritance, if you think that's more interesting. So I'll give you guys 5 minutes. Go ahead.
John, the question from Zoom, or sorry, from Slack is, are you planning to publish a notebook with solutions to the exercise?
I can do that. I'll put out a solutions notebook tonight. All right, so how are people feeling? Do we need more time? Are we good to go? Yeah. And another question, how are people feeling in general about the easiness of the exercises? Are they're easy, too hard, just right? All right, cool.
All right, thank you.
Cool. The next two exercises are going to be a bit more involved, but I'll also give you guys more time, and maybe I can type out some of the answers to those as well. All right, so the next section is polymorphism. It comes from the Greek words meaning many shapes. In programming, it refers to the ability of different objects to respond to the same method call in a way that's specific to their individual types. So it's actually, it's a really convenient, another way of saying that, it's a really convenient way where you can call the method of an object without having to know exactly what type of class it is. So in this example, we've used inheritance, and we've created an MRI scan class and a CT scan class. They just happen to have different attributes. And so they each have a process scan method, which do different things. In a lot of these examples, the process methods just print something because they're examples, but you could imagine this being more complex code, which handles the data associated with an MRI scan or a CT scan differently depending on the class. And then in this little code block here, we have a list of scheduled scans that we're creating. Some of them are MRI scans. Some of them are CT scans. And then we have this function process all scans, which we're going to call. And here we iterate through the entire list. And regardless of whether it's a CT scan or an MRI scan, we call the display details function. And we can call the process scan function. So both of these have the display details from their brain scan class that their brain scan parent class. And both of these have their own process scan functions. So from the perspective of the person writing this code, it doesn't matter if it's an MRI scan or a CT scan, they're calling the same process scan method, and it keeps going. By the way, I kept using the word function there. They're technically methods, because functions, when they're inside of classes, they're called methods. So here you can see it actually running. Depending on the MRI scan or CT scan, it does something different in the processing step, but from the perspective of the person who wrote this code, it doesn't matter. And that's polymorphism. All right, and then here's an exercise for polymorphism, which is a little bit more involved than the previous exercises. We're going to start by creating a scan scheduler class that's going to manage scheduling and processing these scans. It's going to allow adding scans, removing scans, and then processing all scheduled scans. Here we're going to use both encapsulation and polymorphism. Specifically, the class is going to have an attribute which is a list of scheduled scans that's private, and then methods to add to the list and remove from the list. It's easy. And then finally a method that processes everything in the list. And here we have some optional additional requirements on the scan scheduler if you want more of a challenge. I'm going to give you guys 10 minutes to do this, but about 5 minutes in, I'll start typing out my own solution. That way, if anyone's lost or struggling, they can look at that. All right, sound good?
John, there is a question in the Slack about the word segmentation and what that means.
We haven't gotten to that.
Oh, okay, it's still further down.
Oh. Yes, but it's fine to go ahead. Those are a lot of this is just examples that I came up with. So these are just different steps you could imagine happening in this analysis pipeline in this exercise. So segmentation refers to looking at like a scan of the brain and identifying the different regions. When you're actually implementing these, you can just implement them the same way I've been implementing the processing steps, which is to have a print statement. You don't actually have to process any data in this notebook. Does that answer your question?
Professor.
No,
Yes, sir.
no
Thank you so much. Question. Are we scheduling the scans for patient?
I think that this is for like an institution, so there can be scans from multiple different patients. Is that the?
Yeah.
Yeah, but if, I guess it would be a little more complicated. You could try to require that all of them have the same patient name if you want it to be for one patient. I wasn't worried about the patient names whenever.
Question mark.
If to answer the question in Slack, you're correct. I didn't need to use
Yes.
it.
You're right, but perhaps you are interested in looking one specific scan. So, yeah,
I did
it's,
the optional
yeah.
things.
You're right. Thank you, Professor.
So how are people feeling? Do we need more time, or are we ready to go over more time? Perfect, no problem. All right, in the interest of keeping everything on track, I'm going to go ahead and go over my solution to this problem, and then go on to the next topic. All right, so I've created this class scan scheduler with a constructor. Oh, sorry.
Could you make it actually larger?
Oh, yeah, no problem. Okay, cool. All right, so this constructor doesn't take any arguments other than self because we don't need them. All it does is create this list that we're going to use later called scheduled scans. I have this underscore at the beginning to indicate to anyone using this class to not directly access this variable or this property. Next up, we have this add scan method. If you don't do the optional requirements, all it needs to look like is this. Self._ scheduled scans is the list, and then .append adds a scan to the end of the list. But I have this optional requirement that I wanted to highlight. Implement checks to ensure that only scan objects that inherit from brain scan are added, and you can use the isInstance method. This is really good form for whenever you're writing any function or method, which is to check the inputs. Any function or method that's being used by someone who's not you, who's being used by you in the future, because oftentimes when we write a function or method, we know what it does and we know what to expect in the input, but then we use it later and it does something weird that wasn't expected and we don't know why, and a lot of the times it's because we passed something into the function that was not what we intended. So a function has some arguments that it wants. In this case, it wants scan, and what we're doing is type checking, and we're simply asking, is this scan a brain scan? Any class that inherits from brain scan directly or indirectly, even if it's like a child of a child of a child class, will still be true for is it a scan of a brain scan. So we're just doing some type checking here, which I think is really good form in general. And if it's not, then we tell the user of the class to provide a brain scan instead. All right, and then I have this remove scan method. This is the opposite of append. In this case is pop. This should remove the last element of the list. When I post the solutions later tonight, I'll do all of the optional things as well, which would make this a little more complicated.
Sorry, can I ask a question? Shouldn't you add remove the last scan? I mean, because it's so a bit confusing. I mean, remove a scan, or you should at least pass an index to it, or the name of the function should be more clear, I think. I don't know.
Yeah, I think you're right. This should be remove last scan. Yes. Yes, and in the optional requirements, you pass in not the index, but you can allow scans to be removed according to patient name and date. So later tonight, when I post the solutions, I'll post the solutions with a more powerful method where the user can ask to remove by the name and date of the scan. All right, great question. And then finally, we have this process scans method, which uses polymorphism. It's very similar to the example we already saw above. It goes through the scheduled scans, but doesn't care the details of the scan, whether it's a CT scan or an MRI scan. As long as we already know their brain scans, then we can call their methods that every brain scan function has, or brain scan class or object has. All right, now let's see this in action. So scan scheduler was just the blueprint. And in this line, we're actually creating a scan scheduler object. And then we're going to add 2 scans. This is from a list I made earlier. But I'll show you what this could look like in practice. We're just adding in a particular scan. And then here I'm going to look at the scheduled scans, but you'll notice this is bad form. You can look at the private attributes of a class, but you're not supposed to. In reality, this class should probably have some method for printing the scheduled scans if someone wants to do this. But let's look at what it printed. Inside the class, we have these list of scans. They're two different objects. This is showing the class that the object came from. Main is just where we define the class, and the MRI scan is a specific type of class, and this is just the memory address where it's at. So this print statement would look a lot more simpler if they were integers or floats. But once you get used to looking at the outputs of printing a class, it's actually not that hard to understand what's going on here. There's an MRI scan object and a CT scan object. And then finally, we tell it to process the scans, and it just does the same thing that we already saw earlier. All right, let me check if there's questions.
I think as a quick workaround, instead of using a list, you can make it a set, and then you don't need to call it an index. So if you were passing the scans in and you name them first, then you can remove.
Yeah.
But it's basically the same other way.
Yeah, that's a good point. It doesn't have to be a list, it can be a set. Another fun object that it could be is a dictionary. There's a few ways you could implement this that would be more sophisticated than just removing the last scan.
Hello, Kruper. Sorry, I have a question.
Yes, go ahead.
Yeah, thank you. So I'm just like a little. I understand what in the part of the definition of scan. I understand the in instance. I understand the scan. I understand what brain scan does. I understand that perfectly. I'm just like a little bit lost in the script. So that brain scan, there is somewhere where we said that whether an object is brain scan or not, right?
Yep.
I'm lost in what part of the script that was, because that's when I got a little bit messed up with everything. So can you tell me in the script? I know it's before, but where did we say that? Because like,
that's a great question. Let me find it. So this is in the encapsulation section, or really in the inheritance section. In both cases, we're defining a brain scan. But the brain scan, this goes back to inheritance. The brain scan is the parent class. And then after that, when we define this MRI scan, we told it that it inherits from brain scan, so it can use the methods and the properties of brain scan. And let's see where CTs. And polymorphism is actually where we define the CT scan class as well. So both of these inherit from the brain scan class. And that's why when you do is instance on an MRI scan, it will return true, because the MRI scan is a brain scan. Does that make sense?
okay, so it's because all the classes have like kind of like heritage, like they got all this information from the previous classes.
Exactly.
And
yeah.
So there, we don't need to define, for example, whether it's like for example, where it says there a CT or a MRI, it's already defined by the class itself and by also the previous classes that we defined before that. So it's bringing all up like from the first classes that we created, then all the way down. So it's not necessary to say specifically that this is a brain scan or this is not a brain scan. It has been done already by this definition, by the classes and the models, right?
Exactly, that's correct. And if we removed this line here is the syntax for how we tell it that a CT scan is a type of brain scan. If you remove this and redefine the CT scan, then when you do is instance on an object,
it's gonna say that it's not a brain scan.
Yep.
Okay, great. I got it. Thank you very much for that. Sorry, I was a bit lost there.
Oh, that's a great question, I'm sure. Yeah, and I want to show an example of the error showing up. So if you pass something that wasn't a scan at all, like maybe an integer, then it should hit then it'll say is instance of this integer brain scan, no, and it does the print statement. All right, any more questions?
I have one more question about inheritance and the use of the is instance method. If you have like multiple levels of inheritance and you use is instance, could you list in, or put in any one of those names and it would still be true as long as it's one part of that hierarchy?
Yeah, that's a great question. And yes, the answer is yes. I'll repeat it for Zoom. So the question is, if you have, for example, a class, which is a child, well, let's say a class fMRI scan, and that's a child of MRI scan, which is a child of brain scan. And you do is instance fMRI scan, brain scan, the answer would be true. So you should be imagining like a tree in your head. And if your parent, if you've got an object that's fMRI scan, if your parent is a brain scan, or the parent's parent's a brain scan, or the parent's parents is a brain scan, then is instance will return true. Good.
Is there any way to like print off the kind of tree of inheritance?
That's a very good question. I don't know the answer.
This is a much broader question. We've had a discussion about this question in my lab before, and I don't know how to answer it. I'm just hear what you're saying. When do you decide to move from writing kind of standard procedural code to doing object-oriented programming?
That's a very good question. So the question is, when do you decide to switch from doing procedural code to object-oriented programming? Personally, I think I'm a pretty biased person to ask on this. I don't actually use object-oriented programming that often. I think it's really good form. You want to organize this and organize your code, I think, in a similar way to what object-oriented programming does, where methods that do similar things are in the same location. And you've got data structures maybe near those methods, and you're doing type checking to make sure when you pass in a data structure to a method that everything is valid. But in terms of when you actually want to switch over to object-oriented programming, I don't use it that much. I think I've used it for UI stuff before, and it ends up being kind of convenient. I don't have a great answer. It's there's some that this is like a divide, though, I should say, for everyone in the class, because there are some people who use object-oriented programming all the time for what they do, and some people who don't use it much at all. So there's definitely there's many smart people who use it all the time. It's just personally, I'm not one of them. Yeah.
Well, it's certainly important to know how to read and understand.
Yes,
it,
that's
even
true.
If you're not going to be writing it, because when you want to go look at how somebody else is doing things, you want to be able to understand.
Yeah. So he just wanted to add that it's also important to know about it, to understand it, and be able to read it, because other people might be using it even if you're not using it. Right, any more questions? Check the slide. All right, so in Slack, there's a question, well, is instance work for multiple generations of inheritance, or do you need to supply the direct superclass of what you're testing? That's a great question.
That was already answered. Thank you, guys.
Yeah. Another thing to throw in, since you guys haven't learned enough already today, you can inherit from multiple classes. So just so you're aware of this, you can do brain scan and MRI scan, and then it would take methods from both the brain scan and the MRI scan. And if there's some conflicts there, I don't remember how it resolves it, but then you can do is instance on brain scan, MRI scan, and both of them will work. So you're imagining a tree in your mind where it can have multiple parents, and it can go up the list of parents. It all gets very complicated. Right? Do you have a question?
I was going to ask how it resolves conflicting methods.
Yeah, it probably throws an error, but I don't know. Yeah, there you go. Cannot create a consistent method resolution order.
Okay.
Cool. All right. We are 2 minutes out of time. There's one more thing called abstraction. One thing you'll notice is we've been assuming that the class brain scan has had a process scan method, but in the actual brain scan class, we never said that had to be the case. Abstract methods are a way of handling that. You can read this afterwards as well, but here we create a brain scanning class with an abstract method process scan. And now that's basically saying, if you inherit from brain scan, we expect you to actually implement this process scan method. So the generic brain scan is just this like concept. And then when you actually create MRI scan or CT scan, you're going to want to write the process method in that class. So it's providing a template and saying that future classes should follow this template. And then I have a final exercise here, which is quite long, and an optional project. If you guys want to follow up on the stuff, and you can feel free to ask questions in the Slack about any of these exercises or anything we talked about today. All right, any final questions? All right, thank you, everyone.
Thank you.